Let's talk about three-phase generators. To be more specific, 12-wire three-phase generators. My name is Sarel. Welcome to my channel. Please like, subscribe and share, because that would help me grow the channel, which at the end of the day makes it worth having the channel. Okay, let's get started on the generator. If you see me look down, it's because I made myself script notes, because I'm hoping not to forget anything. I will put things totally out of sequence. Okay, first of all, a 12-wire generator with the 12 leads is the end of 6 coils that's within the stator of the generator. Then you've got your rotor, which also has coils inside, which is connected to your voltage regulator. Your voltage regulator is there to regulate the voltage, as it rightfully says, and it does so by measuring the voltage between two of your output points and then correspondingly put out a DC voltage which gets sent to the rotor to create a magnetic field. The bigger the magnetic field, the bigger the voltage that comes out of the stator. Simply how a generator works is the rotor produces a magnetic field which rotates, which cuts through the windings of your stator, and that's how any generator works. Your 6 coils of the stator, depending on the connection you choose, is also what you will get out of it. For example, some connections will give you higher voltages than others. Some connections are for single phase, some is for dual phase, and some is for 3-phase. In following videos, I will go through the different connections. Important to note, when you use a generator or work on a generator, you must always use it within the design parameters of the manufacturer. If you don't do that, you end up either pushing the voltage too high and your insulation can't cope, or in another case you can push your amperage too high and your conductors can't cope. Simple rule of thumb with electricity, it's very similar to the flow of water. The more water you want to move, the thicker the pipe you need. Same with electricity. And that is why with some connections where you have your coils in series, that will necessarily give you a higher voltage. Where you parallel two coils, that's basically making a double the thickness, you get higher amperage you can push through it. Important to note, your voltage regulator can regulate the voltage. It cannot regulate what you draw from the generator amperage wise. So it's very important to make sure that you've got circuit breaker protection rated to what the value of the generator is, and that you will find on the nameplate. Now we've got 2 frequencies that is commonly used throughout the world. 60 Hz in America, 50 Hz in South Africa and most European countries. You can adjust your voltage by adjusting the setting on your voltage regulator. You can also adjust the stability of your voltage. Although I would recommend with the stability setting, it's usually good the way it comes out of the factory. Then your frequency. Your frequency is depending on the speed of your motor. So before you adjust your voltages, first get your frequency correct. If it's 50 Hz you need, if you don't have a Hertz meter, that would be 1500 RPM on your generator. If it's 60 Hz you need, it will be 1800 RPM on your motor. The reason you get your frequency correct first is the speed the generator turns out also determines the voltage it pushes out. So it would be senseless to first get your voltage right and then your frequency, because it will change again when you change your frequency. Now what I'll be doing is there will be videos that will follow on this one, where I will go through all the 6 commonly used connections you get on a generator, and I'll show you how the drawings look. Then I will also show you what to expect voltage wise, and then you can do the connections and get the required voltages. And of the 6, some is for single phase. On some of them you can get single phase and dual phase, and on others you get 3 phase. You are not limited to 3 phase on a 3 phase connection, but what should be considered is if you've got a generator connected in 3 phase, always try and keep your load as balanced as possible, because your engine is usually rated to just a little bit more than what the generator can put out. Now if you are trying to draw all the current on one of the 3 phases, you will burn that phase, because the engine is strong enough to just carry on, because it's expecting the full load, although you've only pulling on 1/3 the capacity of the generator. So always bear that in mind. With your bigger generator it's not a problem, because usually your protection will be as such that it will trip out. But on your smaller DIY type generators, it's not always the case, and that's why people often burn small 3-phase generators. It's with having a too big a load on the single phase side. Guys, I'm looking forward to doing the next videos where I will show you the connections and how to connect. And if there's any questions, just put in the comments. I'm not always very fast with answering comments, but I will get to it. Well, I hope I've helped with what I've explained now. If there's any questions, just ask. Catch you in the next one.